Droids from Galaxy's Edge will go to sleep after about 5 minutes of inactivity. In other words, if they don't receive a command from the remote control in 5 minutes, then they go to sleep. They do this because when the droid is waiting to receive a command from the controller, it's consuming about 13 milliamps of electricity. And if it was left permanently just waiting to receive a command from the remote control, it would use up the batteries in less than a week. So the droid's microcontroller goes to sleep, and in its sleep state, it's only consuming about 15 to 20 microamps. It's about 1,000 times less electricity being consumed when it's asleep. In that state, the batteries in the droid won't drain because this thing's using a little bit of electricity. The batteries themselves will slowly discharge over a matter of years, and that's what will drain the batteries, not the microcontroller. So in that sleep state, the droid, you can think of it as essentially not consuming any electricity at all. Now the way it does that is it turns off everything, including the radio it uses to listen for commands from the remote control, which means that you can't wake your droid up using the remote control. The only way to wake it up is to turn the power to the microcontroller off and then on again. Now with our unit droids, that's pretty straightforward. There's a power switch here down at the bottom here. You just walk up to it, turn it off, and then on again. And the droid wakes back up and it'll start responding to your remote control again. But for BB units, it's a little more involved. The power switch is inside the shell, so you have to take it apart. You have to remove the head, find the split, crack the shell open, and hopefully the motivator isn't in a weird location or orientation that it just falls right out. And then take your motivator out, find the power switch, cycle the power. Hopefully you don't do that. Put the whole thing back together, find those little marks that line the shell up. No, there we go. Like that. Put the head back on, and somehow it goes on like that. And there we go. Now that takes 30 seconds to a minute maybe to do, but it's kind of frustrating, kind of tedious. And what I wonder, and a question that I've seen asked online a lot, which is that really the only way to wake up a BB droid? Do you really have to go through all of that hassle? And the official answer is yeah, you do. But I wondered what a lot of people wonder, could it be made simpler? And so I thought about it for a little bit, and I came up with a solution. To wake the microcontroller up from sleep, you need to reset it somehow, and the way they're doing it is by cutting power to the microcontroller with the power switch. So I followed their lead and I came up with a circuit here based off of this, a tilt switch or ball switch, you can sometimes see it referred to as. And it is literally just a can with a steel ball in it. It's got two leads coming out of it, and when you tilt it upside right, the ball drops down. It completes the circuitry. You tip it upside down, and the ball breaks the circuit. Now, I can't set this up in the fashion that I have here, the battery going directly to the switch here, because the switch is only rated for a few milliamps of current, and your droid will be drawing, especially when the motors are running, over an amp of current. So this is not the way to do it. But a big circuit like this, which uses the tilt switch to trigger a big beefy MOSFET here. That's the real switch. I came up with this circuit. I first tested it out in a circuit simulator, and then I put it onto a breadboard such as this here. There's your big beefy transistor, and it seemed to work fine. So I put together a prototype using some Vero board here. There's the big beefy transistor. There is the tilt switch, and I plugged the battery wires into this connector here, and then this wire plugs into the control board. And when you tilt the droid upside down, it resets or disconnects the power from the droid, and then you tilt it back up the right way, it reestablishes power going to the droid. And it worked. It worked great. No problems at all. So I designed the circuit. I sent an order off to Osh Park, and a week later I had this in my hand, this PCB which I've populated. I have the MOSFET there, and I have these wires here to go between the battery and the Droid, and I put this in there, and it works great. It does exactly what you need it to. You can use your Droid and then put it away. You don't need to turn it off. Let it go to sleep on its own, and then when you want to use it again, just tip the Droid upside down, and this thing will cut power briefly to the microcontroller, and then it'll wake back up when you tilt the Droid back the right way up. It's brilliant. I'm really excited and happy that this works. But there was still something nagging at me in the back of my mind. The microcontroller in BB and R unit droids is a Nordic Semiconductor NRF 51822. I went online and downloaded the datasheet for that particular microcontroller. And here is a section on power management. It talks about a system off mode. And it talks about how the system off mode puts the chip in the deepest power saving mode. This is probably what they're using in the droids. And it says here that the chip will not restart or wake up unless you use the pin wake up mechanism. What's the pin wake up mechanism? Well, it talks about it right up here. Pin wake up from system off, and it says right there, the first bullet point, reset. Reset. I looked further in the data sheet and I found this list which shows all the pins of the microcontroller, and we see right here at pin 23 something called SWDIO/N reset. And under the description here it says system reset active low. What that means is to reset this microcontroller you have to pull this pin, pin 23, low or to ground. So if I connect this pin to ground, that will reset the microcontroller. And if you reset the microcontroller, it should wake up from its deepest sleep mode and start responding to the controller again. So that means all I need to do is take this tilt switch here, connect it between the reset pin and ground, and whenever it gets tilted upright like this, and the ball drops and makes a connection between the two leads, that will put the microcontroller in reset mode. How simple is that? But where is this pin 23? And soldering to that is going to be kind of a hassle because the pins, especially if we go back here and look at this picture, those pins are really tiny. But I also noticed this. It calls pin 23 both SWDIO and N reset. And when I saw SWDIO, I knew that this was going to be the simplest, easiest mod ever. This is a picture of the control board out of a BB unit. There's the microcontroller right there that we're trying to reset to wake the droid back up after it goes to sleep. And just above it here we have this section that looks like it was intended to have a connector on it, but the connector was never added. If we zoom into that section, we can see there's the connector there, and if we flip it upside down, here there's a label in the silkscreen, SWDIO. There it is. There's the pin that we need to connect to ground to reset that microcontroller. But it's actually easier than that. This unpopulated connector here, that is the serial wire port. If we look at the control board for an R unit droid, they've actually labeled that connector SW port for serial wire port. This connector here has 4 pins. We have the microcontroller power, which is usually 3.3 volts. We have the SWDIO pin, the SW clock pin, and ground. We just need to connect these two pins together to cause this microcontroller to reset. Meaning, if we take this control board from a BB unit, which normally is going to be standing vertical like this when the droid is standing upright, all we need to do is take a tilt switch, connect it between the ground and SWDIO pins, like so, bend it over so the barrel of the tilt switch is parallel with the board, so when the board is standing vertical, so is the tilt switch. In this orientation, the tilt switch is not making a connection, so the microcontroller is not in reset. But then when you flip the board upside down, when you flip the droid upside down, the tilt switch, the steel ball inside the tilt switch, drops down. It makes a connection between SWDIO and ground, and that will reset the microcontroller. Tilt it back upright, it disconnects those two pins, the microcontroller starts running like it should normally, your droid has woken up, it will start responding to your remote control once again. That's the mod, a tilt switch across ground and SWDIO, orient the switch in a manner that it's not making a connection when the droid is standing upright, but it is making a connection when the droid is upside down. And then when you need to wake up your droid, just tip your droid upside down, and that's it. To perform this mod, you will need just a tilt switch. You probably want to have a soldering iron too, but you don't necessarily need one. The tilt switch that I'm using is this. It's labeled SW-520D, and if you go online to Amazon or eBay or AliExpress and you search for that, you will find several listings. These tilt switches are ubiquitous and inexpensive. A package of 10 should run you maybe $5. It depends on where you buy from. The diameter of the leads and the diameter of the hole in this unpopulated connector are almost identical. It might be possible to just insert this tilt switch and have it form like a friction fit so that it'll stay in place. And without soldering, you might be able to use this tilt switch to reset your droid. I'm not sure about it yet. I haven't tried it. We're going to try it together in a few minutes here. But that's all you need is a tilt switch, maybe a soldering iron, to perform this modification. Let's begin. I first am going to take the droid apart. The shell and the head can go off to the side for now. We don't need those. And the first thing I'm going to do is I'm going to take off the battery cover and remove the batteries. The reason I'm going to do that is if I didn't do this, there would be 9 volts floating around inside there, and if I inadvertently touch something or make a connection between 2 points on that control board, while the battery is connected to the board, I run the risk of damaging some components on the board and breaking my droid. So I am going to remove the batteries like so. The next thing I'm going to do is to get inside the shell here. There are 4 screws on the corners here. I'm just going to unscrew those. There we go. 4 screws are out. Put those aside. Don't lose those. Now, when you take this apart, do it slowly. You're not necessarily sure where all the wires are that are inside. You don't want to pull things apart too quickly and potentially break any of the wires that are inside. So I'm going to go very slowly here. For me, it's a little bit easier because I've already had this apart a few times, but for you, you might need to be careful here with the amount of force you need to break these in half. And the way I am opening this up is the way I want to open it up. So let me just sort of double check with you. One side has a very long flat section, and across from it is a less long flat section. So you want to tilt this towards the longer flat section. Like this. And there is the microcontroller with all the wires coming out of it. The microcontroller board is held in place. It's a friction fit with a couple of slots down in the bottom here. You can just pull this board out. It might take a little effort. You might need to wiggle it a little bit, but it will come free. And now we need to start disconnecting wires. So the first thing I'm going to do is, it doesn't matter what order, but for me, that's the battery connector there. And then these two connectors are for the motors. And they're color-coded, so you don't have to worry about which connector goes where. And that's the bottom done. We can put that off to the side. We don't need that in our way anymore. Now for the rest of these connectors, it's about the same deal. It's just pull them out, and there's really no need to worry about what goes where, because everything's every connector is only going to fit into one location. You don't have to worry about where things are being plugged in. But the one thing I do want to point out is, well, I've already disconnected it because I've run into problems with this in the past, which is this connector here, which has these thin copper wires coming out of it. This connector goes to the coil in the top of the motivator here. That provides power to the LEDs in the head. These wires are very delicate, so when you're pulling this connector off, don't grab it by the wires at all. You want to grab it by the white connector here, and this will be a difficult thing to pull out. You'll need to wiggle it a little bit, and especially the first time you remove this, it will be stuck in there, and it will feel like you're not getting anywhere. But just keep wiggling at it. Maybe use some pliers if you need to grab onto the white connector and pull that white connector out. Do not, under any circumstances, grab it by the wires here, because they will break, and trying to reconnect that can be a bit of a hassle. Okay, so that's everything disconnected. Here is the control board for a BB droid. And if we look, there is on the top left that serial wire debug port, or the Star Wars port. And I want to connect my tilt switch between the first and third holes like that. The diameter of the lead and the diameter of the hole are almost exactly the same, so it's going to be a tight fit, which is why I said earlier that maybe you don't even need to solder these in. And in fact, I'm going to try to demo that and see if it'll work. So what I want to do is I want to bend the pins, the leads here on the back, just a little bit, so that way they stay and they don't, this thing doesn't jiggle its way out later on. So I'm going to, first I'll try just bending it with my fingers here, but that might be a little difficult. What if I use something like a screwdriver here? Again, I'm trying to be very careful here. I don't want to scratch the board at all. In fact, it might be better to just push the leads in a little bit further. With the leads pushed through the holes a little bit further than what I intend it to be at the end here, I'm just going to grab both leads here, or I could do it one at a time, it doesn't matter, with a pair of pliers like this, and I'm going to try and put like a 90-degree turn on them, like that. That will help keep this from shaking its way out of the socket. And then on the front here, remember the board is going to be like this inside the droid, so I want to bend the leads on this switch so that the barrel here is parallel with the board. So I'm just going to bend it like that. And that's it. That's the mod. Now, if you do have a soldering iron, I definitely recommend soldering it in place, but you might be able to get away with just doing this without any solder. Let's find out. We'll test it right now. So I'm going to start putting these connectors back together. Brown 3-pin connector goes to the brown 3-pin connector. The And I'll explain actually what each connector does. That brown connector goes to the push button and LED that's used to reset or repair your droid. And then this, I believe this is a 7-pin connector. 1, 2, 3, 4, 5, 6, 7. Yes, 7, sure. That connects to the personality chip port. And that is how your personality chip's contents get down to the control board here. The little 2-pin connector for the speaker goes there. The connector for the lights, for the coil I should say, in the top of the motivator for the LEDs goes there. And then I have a power switch connector. This is to turn your droid on and off. That goes there. And then I have 3 more connectors. That's the 2 motors and the connector from the batteries. But for purposes of just testing this to see if it works, I'm not going to use the batteries for now. We can test whether or not the droid resets just by listening to it. We don't need to have it move. And because we don't need to have it move, we don't need to power the motors. I can actually just power this off of a 9-volt battery. So this is a nice easy way to test the droid before reassembling it. Although you probably won't have anything like this available to you. I'm just doing this because I actually haven't done the solderless approach before, and I want to see if it's going to work before I do actually solder this in place. So that's it. I just need my remote now. My remote. And I need to power this on like so. Turn the remote on and... Okay, so it works. There's the switch. That's how it should be positioned, and droid works fine. Now, what happens if I tilt this upside down like this? The microcontroller should be in reset now, and it should not respond to the remote. And it doesn't. But now, if I tilt the thing back up the right way, yeah, that works great. I don't even need to solder the switch in place. That works pretty well. Now, if you have access to a soldering iron, I absolutely recommend you solder that switch in place, because over time there's going to probably be some buildup of tarnish or something that's going to probably break or make the connection here not as good as it would be if it was soldered in place. This thing might also jiggle out of place. It might wear away at the through holes there. So I definitely recommend soldering the switch in place. But if you don't have access to a soldering iron and you're looking for a quick and easy mod like this, this will work. Now I'm realizing that what happens if you push, those pins start to stick out the other end there, and are they going to touch something they shouldn't? They might. So maybe I need to bend this even further down to try and limit just how much wiggle room there is on those leads coming through the other side. Like that. So now the switch isn't going to push through as far, and those leads might not inadvertently touch something and short something out. As you can see, there is a little bit of risk here, which is why I definitely recommend soldering the switch, or the switch in place, but you don't have to. Reset, out of reset. The solderless approach to adding this switch works great. There are, of course, risks involved. If these wires come through and start touching other things, it might short something out. It might eventually sort of wear down the holes, and it will no longer make a great connection, which is, again, why I recommend strongly you solder the switch in place. But at least for a little while, that switch will be fine without any solder. So I'm going to finish the soldering process on this and reassemble this, and I'm going to put this through a real-world test. And there are the pins soldered in place. I will now reassemble the droid. Now we're ready to finish assembling the droid. I will plug the white battery connector in first, like that. The red motor connector to the red connector on the board. The brown motor connector to the brown connector on the board. Everything's plugged in. Now I need to slot the PCB into these slots here on either side. You can see that is where the PCB is going to be held in place. So I'm going to reorient this like so, and that should be in the slot. I'm going to press from the top down firmly to make sure it's in place. And to put the top half back on now, it's just the same as when I took it off. I'm going to sort of hinge it in place so it's loosely on top like this, and then I'm just going to jiggle things around a little bit until the posts fall into the holes. Everything slots into place and it comes together like that. I see no gaps around the side, so that's good. All I need to do now is put the 4 screws back in that holds the top and bottom halves together, put the batteries in, put the battery cover on, and then we're ready to try this out for reals. But actually, you know what? Why don't we, before I go any further, I'm just going to put the batteries in now. Before I start screwing everything together, because maybe I've made a mistake. Maybe in the assembly process I have broken the switch. So let's test it. Let's make sure it's really going to work. Save myself the extra step of having to unscrew everything if it doesn't work. Okay. Power it on. Grab my remote. Power that on. Everything's still good. I'm going to grab the top and bottom halves with one hand like this so I can flip it over. Remember, the screws aren't in yet. I don't want this to fall apart when I flip it over. Flip it over. It's not responding to the remote anymore. Everything sounds good to me, so I'm going to turn that off for the moment, and I'm going to, again, put the screws back in, put the battery cover on, screw that in, and we're ready to go. Okay, BB has gone to sleep. So if this works the way it's supposed to, I just have to flip and then flip it back. Like this. Like a champ. Beautiful. So there you go. There is a very easy mod that allows you to wake up your BB or R unit droids just by flipping them upside down. I think BB owners are probably going to want to do this mod. R unit droids, your mileage may vary. Maybe it's easier for you to tip your droid upside down than it is to try and fiddle with that switch on the bottom of it. But for BB droids especially, I think this is a great, simple mod that is going to have a lot of use. If you have any questions or any comments about the mod or anything else, feel free to ask in the comments below. Other than that, have fun.